So medicine has always been changing in technology. Gene editing is simply the latest in what we have. And what we are now able to do, we can edit many parts of the genome. We can even insert genes where we require. And the therapies are showing 5, 10 lasting years of effect. The challenge is the cost. Because all gene editing therapies, by their very nature, require you to work with cells and modify them. And cost is not going to come down anytime soon, but making it affordable is no more than a bone marrow transplant, for example. Just as we are able to provide high-end services to the country, we can do the same in India as well. But Indian companies must become part of this revolution, these technologies. And my former institute, CSR Institute of Genomics and Integrative Biology, for example, built an Indian CRISPR enzyme, and that will allow these things to occur. So I think it's a long way to go, but I'm already seeing startups in this area taking shape. So see, when you look at the size of teams in India, and you look at the size of institutes in America, they're very different. So a typical Indian CRISPR set of people working on them might be 5 to 10 people at the most, while the total number of people working on the same area in America is very large. Also, historically, the movement of good people has been in one direction, from here to there. But I'm kind of thankful in some ways to President Trump for helping create an environment where many good people are likely to come back. Well, PCSK9 is a great story. It was found by looking at people who thrive in adversity. One could argue that there is no country better than India to find adversity, and finding people who do well despite the adversity will give us gene targets that might be useful. Now, coming to Eli Lilly buying it, that's a new model. Young startups are doing very well because companies that are large are outsourcing risky research to small companies. Whichever succeeds, they buy up, and they don't have to invest their own on the large research. But on the other hand, there have been companies like Johnson & Johnson that has again published a paper on a TB drug after bedaquiline. So we are seeing both ends of the spectrum, companies like Eli Lilly, many others, in cutting edge areas, letting the small university startups do the research, acquire the ones who do best. And on the other side, the big giants with the small chemical molecules continue to produce these in a variety of areas. See, it's a chicken egg problem. Now, if we want India to create valuable startups, somewhere we are assuming that what they do will be paid for very richly by a big pharma company. Now, if the startup is valuable and the science is valuable, the price of that science into practice will also be valuable. So a completely private sector driven science will always be expensive. I cannot see a version where that does not occur. The only way out is to strengthen the public ecosystem and allow high quality partnerships between public and private that reduce the cost of innovation and thereby allow the drugs to come out at a better price point. There is no other way in my mind. No, I think the non-communicable diseases is going to keep on expanding. The biggest of them is going to be dementia. I think at this point, when the median age of becoming demented is in the range of the high 70s and the life expectancy is crossing 80s, the average person will probably be demented before they are dead. And I think once people realize this frightening fact, so much money will pour into dementia and its component syndromes, heart, metabolic, lungs, everything. So we'll see tremendous NCD investments in time to come. So now with generative AI, you can create and screen drugs more efficiently. In fact, even devise new ones. That was not possible. There is a new company called Lila.ai. George Church is one of the founders. The entire workflow of design and testing is completely robotic. There's a recent paper on developing novel mutations in nanobodies in the virtual lab at UCSF. No, actually Stanford. The investigators for AI. So it's an amazing new workflow. Wherever you can afford to be wrong and overall percentage accuracy matters, AI will do well. Wherever the cost of being wrong is catastrophic and there's liability, AI will enter less. So I think in drug discovery, we will see more and more AI in time to come. No, it's already happening. I mean, for example, if you look at IBM's Granite platform, you can work with small chemical molecules using SMILE formulas, put in properties that you want to change, you might get a new formula back and test it. Indian companies are very much in it, Recently, a foundation model called Evo2 has been released for genomic sequences. All kinds of things are happening, and I don't think Indian small companies are behind, but yes, Indian big pharma does not have that relevant talent. That talent is coming out of Indian academic institutions, going into startups, and those startups are interestingly working for global pharma more than Indian pharma. But that will change as the ability to pay changes. So what you're talking about is what's called a protein language model. Just like you have a large language model for English or a language in a sentence, you can think of the sequence of amino acids as a sentence in a protein language model. Then you can say, I want to generate a new protein with the following properties. It is occurring, people are doing it, but to be very honest, this is an area that is not yet fully evolved, but it will occur more and more. People are doing it at bacterial protein levels, but large protein complex levels of humans is more difficult. Can Indians do it? Yes. The challenge for India to do it de novo is, if you take Evo2, it is 9 trillion tokens. To train 9 trillion tokens will take more GPUs the entire government of India has. So governments also today don't have the type of compute power that big companies like X, Tesla, Google, Microsoft have. So we need to solve the GPU problem, and as you know, the access to buying GPUs, even if you have the money, it's non-trivial. NVIDIA has a waiting list for people to get GPUs. So many infrastructural problems to get solved, and the government is trying through the India AI mission to give Indian companies access to GPU powers that the government of India will contract with and procure time. I think that's a good model. There is a need to scale AI in a variety of things, but we must remember what AI can do, what it cannot do. Scanning a radiological image for evidence of an abnormality like cancer will probably be done better by an AI compared to a human radiologist. Interpreting the entire set of findings in a complicated patient who has cancer also and a surgery also and heart disease also, and providing a reasoned interpretation can be done better by a good human radiologist. But a typical radiologist, poorly trained, who only reports findings, AI can do that job better than them. And that's where job displacement will occur. People who are findings writers, information collectors, just implementers of a protocol can be replaced by AI. People who are thoughtful, seeing the patient as a full thing beyond a disease and guidelines, will be difficult to replace. Most doctors in India often gave up mathematics and or computer science before they became doctors. The majority. There will be exceptions to the rule. Trying to give them the foundations of maths and computation, algorithms and AI is not workable. What we don't need every doctor to learn about AI. We need some doctors who are interested with inclinations along quantitative sciences to have opportunities to learn about AI. Other doctors will be users, not developers. Not all doctors are required to learn about AI. I think they should use their time to become good doctors, but we should create opportunities inside at least our premier medical schools for doctors to have an opportunity, if they are so inclined and they show talent and affinity, to have an opportunity to train in it. There is one very simple major problem in clinical trials in India. You cannot pay a patient to participate. Very few people without payments will participate in a trial. To protect the vulnerable class, there is an appropriate rule that you should not pay people. But at the end of the day, it makes it difficult. I don't know the right answer, because I can understand that if people were paid to participate in trials, poor people would get disproportionately enticed into participating, which is unfair at one level. But by not paying people to participate in trials, it will be difficult to get sufficient people to do trials in India. I mean, both are obvious problems. We'll have to pick what we want and live with it.